So, this video is basically to talk about a little bit more into probability that we didn't get to in class. Now, in class, honestly, we just talked about the basic probability. But if you look at that blue reference sheet that you got in class, and the reference sheet that will be given to you on the EOC, you'll notice that there's some other probability formulas and things like that. And so I wanted to come on and do this quick video just so you guys can see how those formulas are used and what they're used for. Okay, the best way to basically talk about these formulas is through an example. All right, so this first example says, in the cafeteria there are 10 chocolate milk cartons and 5 regular mild milk cartons. There are also 8 packages of chocolate chip cookies and 12 packages of peanut butter cookies. If you grab a milk and a package of cookies without looking, what's the probability you'll get regular milk and chocolate chip cookies? Now, in this situation, you have to realize that grabbing a milk and grabbing a cookie are two separate events. They are what is considered independent events, because whether you choose a milk or whether you choose a type of cookie, they are separate from each other. They are independent of each other. Just because you choose chocolate milk doesn't mean you're going to choose chocolate chip cookies. They are completely separate from each other. All right, the probability of picking a regular milk and picking chocolate chip cookies, they're separate from each other. I hope you guys understand that. So there's a formula that goes along with basically independent events, and it's this formula right here that basically says the probability of event A or event B happening is the probability of A plus the probability of B. So in this situation, we're going to let event A be the picking regular milk and event B be picking chocolate chip cookies. Because A and B are independent, we can use this formula right up here at the top and find out the probability of picking a regular milk and picking chocolate chip cookies without looking. Now, there is one thing that I just want to make sure that I correct right here, is that I don't know why it's a multiplication, but I want to change this really quick to an addition, all right? Because you should be adding these two probabilities right here. So there are 5 regular milk cartons and there are 15 total, okay? Because right here we had the 10 chocolate and the 5 regular, so that made 15. So the probability of picking a regular milk is 5 out of 15. And then for our cookies, we have 8 chocolate chip and 12 peanut butter, which make a total of 20. So the probability of picking a chocolate chip cookie is 8 out of 20. And so what we do is we add those two probabilities together and we get 11 out of 15. So the probability of picking a regular milk and picking chocolate chip cookies is 73%, or 11 out of 15. Let's look at another example. It says students at a high school can take one foreign language each term. About 37% take Spanish, about 15% take French. What is the probability that a student chosen at random is taking Spanish or French? Okay, now this is an example of the same thing. Okay, whether you pick a student that speaks Spanish or you pick a student that speaks French, they're completely separate from each other. And so again, we're going to use the formula for independent events, which basically says the probability of event A or B happening is the probability of A plus the probability of B. All right, so we're going to add the probability that a student takes Spanish plus the probability that a student takes French. We'll add them together and we get a total of 0.52, or basically 52% of 52% will either take Spanish or French if we're picking a student at random. Okay, you also have to take into consideration, all your percentages should either add up to 100 or your probabilities should add up to 1. So if your two probabilities that you're given do not add up to be 100 or add up to be 1 if they're in the decimal form, then that means that there are some students who don't take neither Spanish or French. And so that's why, in this case, if you're picking a student that either going to take Spanish or French, is less than 100. Okay, so that's why it's 0.52 or 52%. Now, if two events are not mutually exclusive, okay, in other words, they don't depend on each other, then you have this formula here. This is the probability of A or B happening is the probability of A plus the probability of B minus the probability of A and B happening. Okay, so this is where you have to take into consideration, okay, if you have two different events and there 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 are situations where they share like a number in common or something in common, then you have to make sure you subtract the probability because it's not like you want to count double. I hope that made sense, but let's look at this example. Hopefully it clears it up. It says numbers 1 through 10 are written on index cards and placed in the box 1 through 10. What is the probability that a card chosen at random has a number greater than 7 or even? Okay, so if you think about this, you have the index cards 1 through 10. Okay, if you want a number that's greater than 7, well, those are the numbers 7, 8, 9, and 10. Okay, and if you want an even number, that's going to be 2, 4, 6, 8, and 10. Okay, now if you notice between these two separate events, the event that you pick a 7, or it's a number greater than 7, or that's an even number, you see that they have two numbers in common. Okay, they have 8 in common and they have 10 in common. So that's what I mean, is that if you have two different events and they have something in common, you have to subtract that probability because you don't want to count it twice. All right? So in this situation, so the probability that it's going to be greater than 7 or even is the probability that the number is greater than 7 plus the probability that it's even minus the probability that it's greater than 7 and even. Okay? So basically what they share. So there are, greater than, I said greater than or equal to, so you know what, I'm going to go ahead and take out the 7 and make sure I read the problem next time. Okay, so here are the numbers that are greater than 7. All right, so that's where they got the 3 from. So 3 out of 10 numbers are greater than 7, 5 out of the 10 numbers are even, and 2 out of the 10 numbers are greater than 7 and even. So we add the probability of it being greater than 7 plus the probability of it being even, and then we subtract the probability that is greater than 7 and even, and then we get our probability that that if we go in and we choose a card at random, that is going to be greater than or even, and that is 0.60 or 60%. All right, now this last example is an example of what's known as conditional probability. All right, now conditional probability is a probability that there's a condition put on it, hence conditional probability. And this is a prime example of it. It says at a local restaurant, 40% of their customers order wings. 18% of their customers order wings and fries. What is the probability that someone who orders wings also orders fries? Okay, so I'm not concerned about the people who come in and order something outside of wings. I am concerned about the people who come in who order wings and also order fries. Okay, so the condition is that if they order wings, they also order fries. Okay, now on the reference sheet, you'll see a formula that looks kind of like this. Okay, where it says probability B/A, and then it says the probability of B and A divided by the probability of A. Okay, that is the standard form for conditional probability. All right, and so if you want to plug it in, we have two different events here. We have the event that they come in and order wings, and then we have the event that a customer order wings and fries. Okay, so then we can basically make event A be that they order wings, and then we can make event B being that they order fries. Okay, so when I plug it into my formula, this is basically going to be the probability that they order fries given that they order wings. So then to figure out this probability, I'm going to take the probability that they order fries and wings and then divide it by the probability that they're going to order wings. That is conditional probability. So then when we go to plug in, okay, our probability that they order fries and wings is 18%. We divide that by, I just realized that's not division, that's forward slash. Sorry, fix that. Okay, so the probability that order wings and fries is 18%, and the probability that they just order wings is 40%. And so we basically type that into our calculator. If we want to convert it to a decimal, that's 0.18 divided by 0.40. Okay, and then when we type it in, we'll find our probability that someone who comes in and will order wings also orders fries. And that equals 0.45 or 45% that someone who orders wings will also order fries. And that's conditional probability. Okay, now one thing you have to remember about conditional probability is that the condition is always on the bottom and it always is second in the formula. Okay, as you see, the condition of us ordering wings was second, okay, in the formula, and the probability of just ordering wings went at the bottom. Okay, some people for some reason get it mixed up. Okay, if you have any questions, let me know. You can always go to Khan Academy and look up extra videos on conditional probability, mutually exclusive events, and independent events if this video made no sense to you. But I just want to make sure that we cover this part, considering that we've been hearing from other schools that probability is on more of this type of probability is on your EOC, and I want to make sure that you've at least seen it. Okay, so let me know if you guys have any questions, and until then.